Welcome to Education Lifeline. This is Trishita Paul, and today we will be transforming different exponential functions. Now, if you haven't watched our previous video introducing transformations of exponential functions, the video will be linked in the description below, as well as on the top right-hand corner of your screen. Please check that video out before watching this one. Let's suppose you are asked to graph the following function. F of x is equal to 2 to the x minus 1 power plus 1. We can first start off by writing the parent function to this exponential equation, which would be f of x is equal to 2x. And we get parent functions by setting a equal to 1 and the values of h and k equal to 0, which would leave us with f of x is equal to 2x. We can also write down our reference equation for transformations of exponential functions, which is f of x is equal to negative a b to the x minus h power plus k. And what we want to do is to graph this equation is find the values of a, h, and k. And if they vary or differ from our parent equation, values of a, h, and k, then we must make those changes on our parent graph. So looking at this equation right here, we see we have an a value of 1. We have that invisible 1 right in front of our 2. And our parent function already has an a value of 1, so we don't have to change our graph according to our a. Now we can see that our h is negative 1. We just take the value right after the x, negative 1, and our k is positive 1. What we see here is what we can tell from our h and k values is h is going to move right 1 unit because h deals with horizontal shifts, and k is going to move the graph up 1 unit. And so let's first graph this parent function over here. So we can see a comparison between our parent function and our given function. To graph a parent function, we'll start with the point 0, 1, since 2 to the 0th power is 1, 2 to the first power is 2, then we have the point 2, 4, and 3, 8. So we'll get some graph that looks like this, where our horizontal asymptote is y equals 0. Now, to graph our given function, we have to move the graph 1 point to the right and 1 unit up. So every point we get, we move 1 point to the right and 1 point up. This point here moves 1 point to the right, 1 point up, 1 point to the right, 1 point up. And we'll get something that looks more like this. And notice how we have a new horizontal asymptote at y is equal to 1, which we can see here from our k value. Now let's try an exponential function that has a different a value other than 1. So suppose we have the equation y is equal to negative 1/2 times 4 to the x power. We can once again start off by writing our parent function. Y is equal to 4x. And let's go ahead and graph that. So we start with the point 0, 1 as always. Then we have 4 to the first power, or 4 to the second power, which is 16. That's off the graph, so kind of graph. Once again, notice that our horizontal asymptote is y equals 0. All parent functions should have an horizontal asymptote of y equals 0. Now let's write, once again, our reference equation, which is y is equal to negative a times b to the x minus h power plus k. And finding the values of a, h, and k, we see we have this a value of negative 1/2, and we have no h or no k, which means h and k are both 0. Those have already been taken care of by our parent function. So we have an invisible 0 in our parent function. Now, to take care of our a, let's remember that our a value denotes a vertical stretch, shrink in the graph, and a negative a value denotes a reflection across the x-axis. So the graph is now moving downwards. Taking those things account, we can reflect this first point, 0, 1, across the x-axis to the point 0, negative 1, but now we have to compress the graph 1/2. So 1/2 of 1 is simply 1/2, so we get that point 0, negative 1/2. And we could always check whether we've graphed the right point by plugging in our x value into our original equation. So if we plug in 0 to our original equation, we should get negative 1/2. So plugging in that 0, 4 to the 0th power is simply 1. So we do get a y value of negative 1/2. So we do know that that is the right point. Now moving from there, every point that we have graphed from the parent function should be halved and flipped. So you have the point 1, 4, now that should be 1, negative 2. We had the point 2, 16, which was off the graph, that should now be 2, negative 8. And we'll get exponential graph that looks something like this, with that horizontal asymptote at y is equal to 0 because our k value here is 0. Now, if we're asked to graph a more complex exponential function that has both a, h, and a values other than 0 and 1, for example, something like f of x is equal to negative 4 times 3x plus 5 minus 2, it might be better to maybe create a table of values instead of trying to conceptually graph. So here, for example, we'll create that table of values, x and f of x. So if we plug in a value of, let's maybe change that to a 2 so we can calculate that better. So if we change that 2 to the 5th power when x is 0, 2 to the 5th power is 32. 32 times 4 is 128, times negative 4 is negative 128, minus 2 is negative 130. And we can keep doing that and then plot those points on our given graph. If this video was helpful, please drop a like and subscribe to Education Lifeline. Be sure to watch our next videos on modeling exponential growth and decay, and check the description below for more helpful resources. We include more tips as well as practice problems in the description of every one of our videos. Make sure to leave any questions in the comments down below. Thanks for watching.